So I ended up just finishing part two last night. So I'm gonna just make this video talking about what I did. Um, I thought I thought it was gonna take longer, and I didn't want to make a video and interrupt it halfway through, but it ended up only taking about 15 minutes just because I had factored the code to be pretty flexible in part one, so I could just plug in the new rules and it worked. So essentially, in part two, as soon as people start to arrive, they care about the visibility of seats, not adjacent seats. And so that would be like this L seat here would see, like straight up, it would be an occupied seat, and then occupied and occupied. So this person would actually see 8 occupied seats. And so you have to not just look at adjacent seats, but you have to go through and walk the grid until you come across a seat, or you come across nothing. And so you have to account for both of those cases. And then this one, this L here, would also see just the one empty seat, and it wouldn't be able to see beyond that. We have to assume that it's like the first occupied or unoccupied seat that they can see, and then you base the rules on that. The other thing is you're keying off of, instead of in the first round we're keying off of adjacent seats, we're keying off of visible seats. And they adjusted it so it's 5 visible seats instead of occupied. And so what I did, but other than that, it's the same. So you have to wait until this stabilizes and then count the number of occupied seats. So essentially what I did was I took my seat grid here and I added a new method in addition to getting the visible seats, or in addition to getting the adjacent seats here. I added a method that will get the visible seats, and I set it up so I could get the visible seats in a direction. So what this does is it walks the grid. You give it your starting x, your starting y, and then you give it the delta x to change, in between iterations. So with for example, if you wanted to get the seats to the left of this seat, you would have a delta x of -1, delta y of 0, and that would walk the grid this way until it hits an edge. And if you wanted to go diagonal, you would have a delta x of 1 and a delta y of 1. So it would go 1 over, 1 up. Actually, 1 up would be this way, so that would be the bottom right. Which I think I did this. I think that my comments are not quite correct. This would actually be +1, and then this would be -1. Just because my grid it's in ascending order as you go down these rows and over. But so essentially I was able to just get the visible seats in, and I just iterated through every direction, all 8 directions that they want us to look at: left, right, up, down, and then the diagonals. And then I just wrote a new set of rules. This is part 2. And then I created since Kotlin has first class support for functions, I have this variable here that's actually a function, and it takes in it's the same interface as the rules that I had for part 1, where it takes this grid, it takes an x and a y, and then instead of getting the occupied seats, I had the grid get visible seats given this position. And then I changed this to be 5 for the visible seat count, like they told us here. 5 or more visible occupied seats for the seat to become empty. And then I ran a test on that first, given the input, and I got 26, which was the example result they told us. And then I ran it on my full input, and it worked. So I have that code on my repo if you want to take a closer look. Yeah, it's just a matter of if you factor your code well. The only things I needed to change was an addition of this visible seats method, and then a change in the rules that I passed in. So it was actually not too bad. So yeah, this was a fun challenge, and I will see you in the next one.